the functions of each stage. Okay, let's explain the functions of each stage, each steps one by one. And the first one is system conception. So the operator of the system conception is the business analyst, and the main task of this stage is to conceiving an application and formulating some tentative requirements for the application. For example, we may say we want a web application, and we need 1,000 concurrent of software could support 1,000 concurrent requests, and the average response time should be, for example, smaller than 0.1 seconds. And we also need to use some cloud data centers. That is, we just need to give some main ideas of the application. And the second process is analysis. The analyst scrutinizes and rigorously restates the requirements from system conception by constructing models. The analyzed model is a concise, precise abstraction of what the design system must do, but not how to do. It means we only focus on what the system needs to do, but without considering how it will be done. And the analysis model has two parts. The first one is the domain model, and the second one is the application model. In the domain model, we usually describe the real-world objects reflected within the system. For example, if we want to develop online text calling system, it means there are so many this kind of softwares. We can call taxis from apps of our cell phone and so on. In this kind of systems, taxi, driver, customs as objects in the real world, and sometimes and in the application models, we need to describe the parts of the application itself that are visible to the user. For example, in the online taxi calling system, it is the request submission component and the payment component. All of these components or parts of the system are visible to users. We also need to consider the relation between these objects. It means we have different objects. Some are the real-world objects, and some are the system component objects. And in order to describe the relation of these different objects, we need some graphic notations. And three kinds of widely used notation is the class model, state model, and interaction model. And in the system design, just now we have explained the system conception and analysis. In all of these two stages, we only focus on what needs to be done, independent of how it is done. But in the design phase, developers make decisions about how the problems will be solved. It means how to implement the functions of the system or how to designing the system. And in this stage, the main task is to devise a high-level strategy. It means the system architecture for solving the application problem. And for example, we need in this stage, it mainly includes the organization of system into subsystems. It means we need to divide the whole system into different parts appropriately, and we need to make some policy decisions. For example, appropriate communication protocols between subsystems and the task scheduling policies in some subsystems, and appropriate memory buffering strategy, and also cloud resource auto-scaling strategy if you use some cloud data centers. For example, this web application is deployed on the washing machines elastically rented from public clouds, then you need to make some resource auto-scaling strategies. For example, we may say that we need to rent more washing machines when the workload is here, and release the resources when the workload decreases. And we also need to make some reuse plan. For example, to add some libraries or common libraries, and these libraries implement some common functions, and they will be reused by different components. And we also need to decide how to store the data. For example, you store the data in an XML file or to a relation-based database or some other distributed file systems and so on. So it means you need to make some decisions, make some high-level decisions for this system. So it is called the system design. The architecture, some policy, reusing plan, data storage methods, and so on. And then it is the next stage is class design. In this stage, we need to add more details to the analysis model in accordance with the system design strategy. In the system design, we have said that we have decided how to implement, how to divide the system, how to some policies. It means in this stage, we need to determine the data structure and algorithms needed to implement each class. Because in the analysis, in the system design, we also have classes. We also use some class models, class diagrams. But at that stage, maybe all of it didn't focus on how these functions can be implemented. But now in the class design, we need to determine the data structure and algorithms needed to implement all of these policies and some other functions. And finally, it is translate the classes and the relations developed during the class design into a particular programming language, database, or hardware. It means only at this stage we will focus on the programming language and focus on how to use this programming language to implement all of the classes and the relations of the system. And some important notes. All concepts apply throughout the system development life cycle, from analysis through detail to implementation. Usually we do not use waterfall development process, but it is more popular to use an iterative process. It means we will revise the models iteratively. And some classes are not part of analysis, but are introduced during design or implementation. It means that in the analysis stage, we only focus on some important classes. For example, focus on those classes in the real world or some classes visible to users. But in the designing phase, we will focus on some when we are focusing on how to implement these functions or how to solve these problems, we may add some new classes. For example, some classes for the different scheduling policies. For example, some classes for auto-scaling the resources, and some, for example, some feedback controlling methods for controlling the performance of the requests. It means that besides the classes added in the analysis stage, we will also add some new stage classes necessary to the system during the design or implementation. And just now we have mentioned 3 kinds of class models, and now we will introduce it one by one. So the first important model, it is a class model. It describes the static structure of the objects in a system and their relationships. A class diagram is a graph whose nodes are classes and whose arcs are relations among classes. And the class model will be used in the domain analysis and in the application analysis and in the system design, class design. It is not only used in the class design. The class model will be used in the domain analysis. It means class model will be used in the analysis stages too. For example, this is a class model. This is the class model for an ATM software. It is we will often use the ATM. We can deposit money or withdraw money from ATM, but it is but in the ATM there's a complex controlling software, and this is a class model for describing the classes of the software and their relationships among different classes. And the second model is the state model. The state model describes the aspect of an object that change over time. And the state diagram is a graph whose nodes are states and whose arcs are transitions between states caused by events. And usually, one state model only involves with one class. It means a state model is designed. We will need to draw a state model for one class at a time, but it doesn't mean that every class will have a state model. We only draw state model for different classes when it is necessary, and the state model describes the state changes of this class over time. For example, this is a state for a chess class. It means it describes the white's turn or black's turn and describes the change. For example, when the start, it is a white's turn, but after the white moves, it will be the black's turn, and after black moves, it will be the white's turn. And this is the event, and this is the state, and after this arc means the events. This arc means the state transition caused by the events, and this all of the on the state model. We need to remember. We need to be careful that usually one state model is for one. It is used to describe one class. And the third is the interaction model. Actually, for the interaction model, there are different kind of diagrams. The interaction models describe how the objects in a system cooperate to achieve broader results. It means that The interaction model describes the relations, not relations, describes the interactions between or among objects. For example, for the use case is a kind of interaction model. It focuses on the functionality of a system. And the second is the sequence diagram. It shows the sequence of interactions. And third is activity diagram. It elaborates important processing steps. For example, we can draw an activity diagram for an algorithm. For example, this is an example of a use case. In a use case, here are different functions of the whole system, and we need to divide the whole system into different functions. And here are some, for example, users or some or some other participants who are or that interact with the system. They are not the components of the software, but they interact with the system.